All right, welcome to lesson 1.1 with Mr. McTavish. This is plotting points in the 3D coordinate system. Thank you, first of all, for taking this time to extend your learning and try this extra bonus unit. The goals in this little lecture here are to learn how to plot ordered triples in the 3D coordinate system. I want you to understand the notation. We're going to talk about inputs and outputs of a three variable function. Okay, you should have a printed off worksheet, and you're in the right place if you're watching this video. So let's get started. Up until now, we've been talking about 2D coordinate systems. And we've worked with ordered pairs that look like this, points that are containing x's and y's, the input and the output. They look like this. Now, in a 3D coordinate system, things look differently. A single point has three pieces of information: the x value, the y value, and the z value. Now, typically, and this always isn't the case, but typically x is coming out of the page, y typically is going to the right. So actually a very standard way of drawing this would be z up, y to the right, and x is coming out of the page. But that being said, I often see y coming out of the page and x going off to the right, depending on where you're looking. We can also spin this whole thing, and that would just change what we're looking at. But z is almost always drawn to the going upwards and downwards because it is considered our dependent variable, and x and y here are our independent variables. Okay, now let's dive right into it. Plotting points. This is where things start to get a little different, and you can immediately understand what we mean by 3D graphing. So let's start plotting these points. All right. So I say we have the point P1, 4, 2. That's x is 1, y is 4, and z is 2. How do we do this? Well, let's start on the x axis right here. We're going to 1. Okay, so that's our 1 part. And what a lot of people like to do is just kind of, when they're first doing this, is draw it out. So we're going to 1, and you'll see what I mean by draw it out here. Y is 4. Okay, so we're going all the way over to 4. And right now, what we have is a parallelogram that has formed. Okay, do you see it? Hopefully you see it. All right, now we got z is 2. Now that's 2 up here. Okay, and we can draw another little parallelogram over here to show you kind of the relationship between the each variable here. Now that's going to go over here, and boom. If we go up from this point, 2 values, we hit point P, which is 1, 4, and 2. So you can see here that I've drawn a three-dimensional box. This kind of shows you where we are here within three-dimensional graphing. As you can see this way how it is in fact going in all three dimensions with the x, y, and the z. Now, just to tidy things up a bit, I'm going to erase this box, and I'm going to leave my point for you. Darn. Let's get rid of that box, but leave the point. All right, because otherwise things are going to get a little bit messy around here. But I'll draw it out each time. Q, second point. Now, please stop the video now if you haven't already. Try it yourself. You've got the worksheet, and then start it up and see if you have the same thing I have. Or feel free to watch again. So Q, we have x is -2. All right, this graph, just to keep things, this grid for the exercise is just to keep things simple. It's going to ask you to draw some of these values in. So in the negative direction. So this is -2. Y is -3. And now we're sketching here, right? So don't worry too much about it. It's not going to be perfect. Okay, we got a parallelogram forming here. Here it is. All right, now I need to go down 2 from here. Okay, well, if I go down 2 from the origin, that's -2 here. And you can imagine, take your time, the box that forms from this. I said take your time, and then I didn't do it myself. All right, imagine that box forming, and there we go. That looks pretty good. If your box doesn't look good, draw it again or adjust the point. but we're sketching, so this looks about right. Um, Now we're all the way in the back here in the bottom part. And I'm going to get rid of all of this, all of this extra stuff so that it's not too hard to see what's going on in this graph as we continue with points. This is point Q. Point R is -1, 4, and 3. Again, pause it, try it yourself. -1, 4, and 3 is upward. So -1, my parallelogram. I'm going up 3 from here. So up 3 from the origin is here. Go back here, and there it is. So just go up. So once you have this point here, what a lot of people like to do is just go up 3. I kind of like to visually map it out because it's hard to measure 3, but basically you want the same distance here coming up from the back here. And there we go. There's point R. Okay, I'm going to get rid of my box here. If you want to leave the boxes that you drew, that's fine. Got a lot of points going on here. R is right there. S, 0, 0, 0. That's the origin. That's the easiest one. Thank you, Mr. McTavish. T, point T, 2, -1, -3. Pause it, try it. 2, it's right here. -1, right here. -3, down 3. Let's draw our parallelogram. There we go. Then we're going down 3. There it is. Nope. Is it? Yep. Sorry. Thinking about here myself, we got over 2, over 1. So that puts us here and down 3 from there. Perfect. There we have 2, -1, -3. Okay. So talking about functions. Okay. In the two variable world, we just spent a bunch of time working on units with functions. This is function notation. We did two variables where f of x is our y value, our output value. And then we have things like this is slope-intercept form. We've got slope point form here. Here we have a constant function. And here we have standard form. Okay, so lots of different ways these things can be written. Typically, when f of x is isolated, y is isolated, we use f of x, but sometimes when things get kind of mixed together, a lot of people like to just use y so that it stays simple. You can, if you're comfortable, you can do whatever you want and try to keep it straight. But conventionally, it's totally okay to switch to y, especially when f of x is being moved around. Okay, in 3D graphing, things get different, okay? We have the form z equals f of x, y, x comma y, where x and y are input values in the real number system, okay? That can be anything, that's x, y, the real number system. And we can have all sorts of different types of functions. Here's some examples here written in the explicit form, meaning that y is isolated. Just like in two-dimensional functions, okay, we have things that look like a constant function here. Okay, sometimes we have f of x, y here specifically is our z value, I should say. So that's z. It can be equal to just x, it can be equal to just y, it can be equal to both, it can be equal to x plus y plus a constant. And we can also have standard form where z is written in and everything's on one side kind of being mixed together. And with this type of function here, we can have all sorts of different situations that we apply it to. Now, how do we use this? What can we do with it? Just like a two-dimensional function, we can, or two-variable function, we can input values and get an output. So I want all my outputs here to come up on this little graph because I want to I'm going to generate 3 points and they're going to come out on the graph. Now, if you want to try this all by yourself and just you think you know what to do, go for it. I suggest choosing some small values for X and Y. Pause the video, give it a try, or just stick around for this little explanation. The easiest point to get obviously is going to be X and Y are equal to 0. So f of 0 comma 0 is 2 times 0 plus 0. That's equal to 0. So there's a really easy point to get. Let's do another point. Let's try 1 and 1. F of 1 equals 2 times 1 plus 1. That's going to be equal to 3. So we have 1, and we're going up 3. So right here, there's our next point. Sorry, I like to use the graph to visualize where these points are. Let's call this point P. Let's call this point Q. Now let's find some more points. Okay, let's go with -2 and 2. F of -2, 2 equals 2 times -2 plus 2. That's going to be -4 plus 2 is -2. So we've got -2 here. Let's call this point R. We've got -2 right here. We've got +2 right here. So we're going to need to go down 2 from this point. Down 2. That's right here. That's going to be point R. Okay, what's happening here? This isn't forming a line. Or is it? Okay, this looks different, but so we can ask the question, what would happen if we kept putting more and more points here? Like, I don't know, let's do some really basic ones. Let's say X is 0 and we got 1. Well, then Z would be, in that case, Z would be 1. So we got 0, 1, and 1. That would be right here. I want you to think about that. What if we just kept putting more and more points on? What would happen? The next lecture is going to be about this. Okay, so you can think about it. Now, if you've finished watching the video, feel free to go back through it. But I've got a little section here for you. Check your understanding. I want you to pause the video. The solutions are in OneNote, and you can also hang on to watch me kind of go through this right now as well. So pause the video, try all the questions, watch them as you go. Okay, and we're off. Using question 1, using the convention established in the lesson, give an example of an ordered triple that is to the right, downwards, and coming out of the page relative to the origin. Okay, so let's break this down. To the right. To the right. Okay, that's y. And is y going to be greater than 0 or less than 0? It's going to be greater than 0 because it's to the right. Okay, downwards. Downwards. Are we talking about x or z? We're talking about z. Is z going to be greater than 0, meaning positive, or less than 0, meaning negative? It's going to be less than 0. Okay, and coming out of the page. Out of page. Okay, that's going to be x. Out of the page, is that positive or negative? That is positive. So let's choose a point that has positive x, positive y, and negative z. Let's go with 1, 2, negative 3. Easy as that. And you could have chosen any values that fit that form and structure. Okay, next question. Identify the 4 ordered triples represented by the 2D and 3D images below. Okay, we got A, B, C, and D. Let's look over here first. We got a view from the X, Y direction. We have a view from the Z, Y direction. Or we could say the xy plane and a view of the zy plane. Now, let's start with A, the green one. Okay, well, looking over here, I can see that A is at y equals 4. So let's start sticking this stuff in. X equals, that looks like -3. Okay, does that line up? Okay, y here, we're over in the positive for the y, negative for x, and z, I know z's going to be negative, so let's have a look over here. Z is down at -4. Okay, B. Let's try B. For B, we have x is 1, y is 3, and it is up in the positive z, and we have a value of 4. Okay. Let's go with C. We have -2 and we have -3. So -2, -3, excuse me. And looking at this, you can see that it is below the xy plane, and that's going to give us a value of also -3. And D, let's find D. It's over here. Okay, positive z, looks like a positive x, and a negative y. So D, positive x3. We got -3 for y, and for z, we have -3. Nope, looking at the wrong one. Positive 2. Awesome. All right. Using the following functions, find 4 points that would be visible on the graph below. You're going to have to do a little bit of mental math to kind of figure that out. So I like to choose x and y being equal to 0 to start. F of 0, 0 equals -2 times 0 plus 0 plus 1. That's going to give us 1. So 0, 0, and 1. Now we could, we just have to do 4. So we can choose whatever we like. 1, 1. Let's do f of 1, 1. It's going to be -2 times 1 plus 1 plus 1. That's going to be 0. So 1 and 1 and 0. There you go. So let's call this point P. Let's call this point Q. Let's do -2 and -1. That's going to give us f of -2, -1. It's going to give us -2 times -2 minus 1 plus 1. That's going to give us 4. So x is -2, y is -1, and we're going up 4. Just going to give us put us up here somewhere. Let's call that point R. Now let's do an easy one to finish. Let's go with f of 0 and 2. F of 0 and 2 equals -2 times 0 minus 2 plus 2 plus 1 equals 3. So 0, 2, and 3. Okay, and we'll call that S. All right, you're going to have something that looks totally different, but hopefully your strategy was the same. Okay, last one. Choose 3 ordered pairs which will form a diagonal straight line when plotted. Show that they will form a straight line without graphing. Okay, in order to do this, I'm going to go into my solution section, so you can go have a look at that too if you'd like. Now, there's lots of ways to do this. Okay, but here's one way that I came up with. It says specifically show that they will form a straight line without graphing. Okay, one strategy you could do this would be to let x1, y1, z1, x2, y2, z2, and let x3, y3, z3 be three-ordered triples. So one way of constructing these triples would be to choose the first 2 points, then calculate what the third point would need to be. Okay, so basically the difference between all of the x values, or x1 and x2, and y1 and y2, and z1 and z2, okay, the difference between that and our x3, x2 value, y3, y2 value, z3, z2 value need to be proportional. This is to say we can multiply by the same constant to get these values. Okay, I'll show you what I mean here. This should be, let's choose our first 2 points, P1, 2, 4, 6, P2, 3, 7, 9. Okay, so x2 minus x1 times a q value that we choose. Let's let q be 2. Okay, should be equal to x3 minus x2. Okay, so if we choose x2 and x1 and q, we can then calculate x3. So basically what we're saying is the change in x needs to be consistent and proportional. So if we calculate our change in x from point 1 to point 2, we get 3 minus 2. That's x2 minus x1. It's going to give us 1 times 2. That should be equal to x3 minus x minus 3. Y3 minus 7 equals 2 times 7 minus 4. Z3 minus 9 equals 2 times 9 minus 6. Calculating each one, I get x3 equals 5, y3 equals 13, and z3 equals 15. So a third triple, third pair would be 5, 13, and 15. Okay. In a subsequent lesson, we're going to learn about this. We're going to talk about slope within 3 dimensions called the direction vector. Thank you for watching, and be looking for your next lesson. Bye now.